Hey, welcome to the podcast on inverse trigonometric functions and inverse trigonometric relations, and they're not quite the same thing. So we're going to start talking about inverse trig functions, and uh, you may be saying, how is that possible? Because if you look at this here graph, which is a graph of cosine x, right? Um, if I look at this graph, uh, it's not an invertible function, right? It passes the vertical line test, so it is a function, but it's not invertible function because it fails the horizontal line test. In other words, if I were to invert x and y and change the variables, this would no longer be a function. Uh-oh. So how can I have an inverse trig function if the function's not invertible to begin with? Do you like my animations? I worked really hard on them. Okay. So this is another way to say that same thing. There are many angles that have the same cosine value. And the way that I can see that on this graph here is if I think about it, the cosine value is the y value, right? So like this up here is a cosine value of 1. I'm trying to make it so that I can point to things. Up here, this is a cosine value of 1. Down here, this is a cosine value of -1. This is a cosine value of 0. And if I pick some random place, right, like here, around here would be a cosine value of like 0.7 or something like that, right? And I can look and see all the places where the cosine graph is at that y value. These are all the different angles that have a cosine of 0.7. There are lots of them. In fact, there's 6 of them on this picture, but if the graph actually showed the entire function y equals cosine x, which remember goes all the way from negative infinity to positive infinity, there would be an infinite number of angles. So there's an infinite number of angles that would have the same cosine value. Huh. So how can I have an inverse function? That's a great question, but somehow your calculator manages to do it, right? Like, and you've been using this calculator button all through geometry to solve triangle problems, right? When you had problems that were like, here's a right triangle, right? And I know that I'm looking for this angle theta, and this side here is 3, and this side here is 5, and I want to find what that angle is. I would say, well, cosine of theta is 3 over 5, and theta is inverse cosine of 3/5. And your calculator manages to do that somehow. I actually don't have a calculator up right now, so I'm not going to actually calculate that. But you could, and maybe you should, if you have your calculator, pause this video and calculate it right now. It only gives you one answer, right? It doesn't tell you all the different angles that have a cosine value of 3/5. It just tells you one angle that has a cosine of 3/5. So something is going on that is kind of fishy. And really what this is all about is this idea of the principal branch. So principal branch is saying what we're going to do is we're going to take part of the cosine function, not the whole thing. We're just going to take part of it, and we're going to restrict the domain so that the part that I'm looking at is invertible. Okay, I'm going to just, instead of looking at the whole cosine graph, I'm only going to look at a part of the cosine graph that is invertible. So uh, okay, what part of the cosine graph would be invertible? Actually, I have a couple more requirements than just, oh, let me move this up, the fact that it is invertible. This is what I need to define the principal branch of cosine. It needs to be invertible. It needs to contain each possible y value exactly once, and it needs to contain the angle 0. Okay, let me try and explain on the graph what exactly this is talking about. So if I look at this cosine graph, and I want to choose a section of the cosine graph that is invertible, right? I can't choose, for instance, this section, the section of a period that goes from negative pi to pi, right? Because that's still not invertible. It still fails the horizontal line test. There's still more than one angle in this section that has a cosine value of whatever it is I'm looking for, 0.7 or anything else. So that does not work. Okay, let's make it a second attempt. What if I said, okay, I'm just going to pick this part of the graph. Okay, now that's invertible, right? There's only one place where there's a cosine value of 0.7, but there's no place on this section that has a cosine value of -0.7. So this doesn't work because then I would never be able to calculate the inverse cosine of -0.7, which is a perfectly valid cosine ratio. Okay. So let's think about this. I want to have an invertible section, has all the possible y values exactly once, and contains the angle 0. So you may be thinking right now, there's kind of two choices for cosine, but the one that's positive is the one that is more convenient. This is the section that I'm going to use as the principal branch of cosine, right? It meets the three requirements. It's invertible, passes the horizontal line test. It contains all the possible y values on the cosine graph, so for all the way from -1 to +1, exactly one time, and it contains the angle 0 right here as this endpoint. So this is the principal branch of cosine. Sweet. Um, Principal branch. Okay, and the principal branch for cosine is from, in terms, I have this labeled in degrees and radians. So in degrees, the principal branch of cosine is 0 is less than or equal to theta is less than or equal to 180 degrees. Awesome. In radians, looking at that same section of graph and just giving you the radian range, the principal branch is 0 is less than or equal to x is less than or equal to pi. That is the principal branch of cosine. So now, if I wanted to do inverse cosine, right? Inverse cosine of, let's do a unit circle value so we don't have to use our calculators. The inverse cosine of 1/2. Okay, inverse cosine of 1/2. There's lots of different angles that have a cosine value of 1/2. The one that I want to pick is the value between 0 and 180 degrees that has a cosine value of 1/2. So which one is the angle between 0 and 180 degrees that has a cosine value of 1/2? Well, if I think about it enough, or I look at my unit circle, you can convince yourself that this is 60 degrees. Or if I were in radians, the inverse cosine of 1/2 would be pi over 3. Okay. Let's do a negative example. What is the inverse cosine of negative root 2 over 2? So what is the angle that has a cosine value of negative root 2 over 2 and is in the principal branch of cosine? Well, thinking about the unit circle from 0 to 180, the angle that has a cosine of negative root 2 over 2 is 135 degrees, or in radians, that's 3 pi over 4. Okay? So we're going to talk about this a little bit more in a while, but for now, let's think about what the principal branch of sine and tangent are. Okay. So here I have a sine graph and a tangent graph for us to take a look at. And remember my three criteria for the principal branch. The principal branch needs to be invertible. It needs to contain all the possible y values of the function, and it needs to contain the angle 0. So if I look at the sine graph, the candidate is obvious. It's going to be this, oops, I'm just going to draw with my pen here. Sorry. It's going to be this section here. Okay, this is the principal branch of sine because it contains all of the different values that sine can be from -1 to 1. It's invertible and it contains 0. So the principal branch of sine right? In degrees, or I lied, it's -90 is less than or equal to theta is less than or equal to 90. Or in radians, it would be negative pi over 2 is less than or equal to x is less than or equal to pi over 2. So you may be saying to yourself, that's annoying. Why don't you pick the same principal branch that there was for cosine? Well, cosine's principal branch was from 0 to 180. So if I look at the sine graph, 0 to 180 would not work as a potential principal branch for sine, right? It's not invertible and it doesn't contain all the values from -1 to 1. So that doesn't work. And it turns out because sine and cosine are offset the way they are, there's no range that I would meet the criteria for both sine and cosine. Like I could not possibly, even if I tried really hard, pick the same principal branch for sine and cosine because I can't meet the requirements for both on any particular range of angles. Let's do a couple quick example problems of inverse sine. So inverse sine of, uh, let's say, root 3 over 2, and let's give our answer in radians. What? Okay, so inverse sine of root 3 over 2. So I think about what on the principal branch of sine has a sine value of root 3 over 2. And if I think about it, I get that it is pi over 3. How about, let's do another one. Inverse sine of negative 1/2. Let's think about that. What on the principal branch of sine has a sine value of negative 1/2? So I'm thinking from negative 90 to 90, I want to go down, so it's going to be negative something. And it's going to be, it's going to be negative 30 degrees, which is the same thing as negative pi over 6. Okay, let's do tangent real quick. Um, where is tangent's principal branch? Again, if I want to meet the requirements, it has all the potential y values. Um, it is invertible and it contains 0. It seems like a natural choice for tangent is just going to be this zoop that is close to the origin. Here we go. Okay, so this is the principal branch for tangent. That was awesome drawing, but you get the picture. It is, and careful, it looks like it's the same from sine, but remember that tangent is undefined at these asymptotes, so they can't be included in the principal branch of tangent. So it's going to be negative 90 is less than theta is less than 90. So notice that sine was less than or equal to tangent. Is just less than, or in radians, it would be negative pi over 2 is less than x is less than, oops, I even just screwed that up, is less than pi over 2. Okay, so that is the principal branch of tangent. Let's do one really quick example. What is inverse tangent of negative 1? Okay, so I'm thinking, what is the angle in the principal branch of tangent that has a tangent value of negative 1? And it is, that's when the u and v values are the same, so this has got to be one of those 45-degree reference triangles. Where is it negative? It's when I go down, so this has got to be negative 45 degrees, or negative pi over 4 if I'm in radians. Okay, that is the end of the first half of the inverse trig functions vodcast.